Here we go. All right. So thank you everyone for joining. It's a really great turnout. I was saying before we got started, this is one of our most popular events out of the year, our Earth Day webinar. And this year it's all focused on energy efficiency. Tonight we have three fantastic panelists from Massachusetts and Maine with us. I'll start with you, Bridget. You work for Efficiency Maine Trust as an independent administrator for the programs that promote energy efficiency, alternative energy resources, and carbon saving in Maine. I know before then you were working in the state of New York, so you've got a lot of perspective and over 17 years of experience. And so we're really excited to have you here tonight and all of the expertise that you bring.
Thanks so much.
Chris Mazzola joins us from Sagamore Beach from Home Energy Raiders as a founding member of that company. Chris, you have way too many accolades that look like tongue twisters, but over 20 years of experience doing energy efficiency work. And so we're excited to have you tonight and all the insights that you have, and especially in Massachusetts.
Cool.
Austin Gregory is joining us tonight. He is a structural engineer with over 14 years of experience. He's one of the founding members of Backyard ADUs, and Austin always provides this lens of energy efficiency when it comes to building small spaces. So thank you guys all for joining us tonight. All right, we're going to break tonight down into sort of three sections, and as we go, we'll have some questions for the panelists, and then I'll be again monitoring the Q&A for those insights coming from the audience. So these days we're building all electric homes. We're not touching gas, and I want to dive into what that means. So Austin, maybe we'll start with you. As you're thinking about and designing an all electric home, what does that look like?
Yeah, I think you just said it. We've got no gas, no fossil fuels in our homes. That means things like stoves. We use induction stoves or electric stoves and electric ovens. We're using electric heat. We are installing heat pumps generally in our projects, which is a version of electric heat that I can get a bit more into. But the idea is when you build an all electric home, you can be fully clean energy. So whether it's solar panels, whether it's wind power, some versions of nuclear, you can have a fully cleanly powered home from the start. There's no transition period. A lot of people make the argument, well, don't you still have your electricity provider coming from fossil fuels? And for most of us, that's going to be true. But it's a lot easier to transition if you already have the infrastructure in place as a fully electric home to go fully electric. Than it is to then transition once the grid catches up. So that's generally what all electric means to us.
Chris, when you're doing modeling and projections, we're mostly exclusively using mini splits. And so how do you think about those systems, putting them into the all electric home, and what are things you're looking for or speccing?
Sure. So when we do our preliminary modeling, we do look for a high HSPF 2 rating for these cold climate heat pumps. So something definitely north of 9.5. 10 or 10.5 is a great HSPF 2. That's the efficiency rating, the metric we use now for heat pumps. It's basically the AFUE. Heat pumps can be challenging. It's an electric heat, but it's not the electric heat that a lot of demographics remember growing up with. It's not radiant floor. They're very efficient, but they can still be expensive. Depending upon, what municipality you're building in or living in. Massachusetts is very inconsistent when it comes to costs for energy. Towns like Braintree it's 11 cents a kilowatt. You get onto the Kate, we're 44 cents a kilowatt. So you got to look at what your expectation is. And if it is all electric home, you're looking for a low embodied carbon home. I have a green footprint concern. Then solar is probably a huge part of that build. And we try to build the most efficient home you can with the smallest PV array. Because that's what will reduce that embodied carbon footprint.
Also, when we're designing these homes, how do you think about that net zero ready, tying that solar component together, and what do you look at?
Yeah, so
So-
there's
Yeah, go
lots
ahead,
of things.
Austin.
Sure. There's lots of things associated with the net zero ready. Part of it is just designing right from the start. So adding insulation up front means that you're going to reduce your heating and cooling load. And a small amount of insulation goes a long way. So small additional insulation. Orienting your windows the right way. So in the northern hemisphere, we're generally orienting our windows towards the south. That's where the sun is. And if you can orient your windows towards the south and fewer windows towards the north, you can get what's called passive solar gain, which can add a lot of energy to your house without anything, without solar panels, without adding any kind of electricity. So making those smart upfront decisions can already reduce that. And then we use smart design. We use heat pumps. Like we said, heat pumps can be up to 400% efficient. Basically, what heat pumps do is they steal energy from the air and they bring it into your house. And you think, even on cold days, is there thermal energy in the air? And there's still a lot of it. So our modern heat pumps, we can steal energy from the air and we bring it into our houses by compressing it. And we have heat in our houses. So that's the benefit of heat pumps, is they're super efficient. So even though they might cost more depending on where you live from an electricity standpoint, 44 cents a kilowatt hour is quite high. They're far more efficient. So we add all of those systems together, and we can use a very small solar array. The other part of that is making sure you have a roof that is facing south, because that's where the sun's coming from, and making sure you have the space to add solar panels. And then also you've prepped for that. We put conduits in all of our houses. We make sure that all of our houses have south-facing roofs that can handle a PV solar array, a traditional solar panel array, that will provide enough power to power that house and make it net zero.
Great, thanks, Austin. Chris, you were talking about all these different numbers and efficiency, and a question I get asked a lot is, hey, what about these heat pumps don't work so well when it's cold? And maybe like that, how has that evolved, or how has the heat pump technology changed? Maybe not, what are all these different numbers mean, but overall, how does it perform in our climate here?
Yeah, sure. So, in the last, I'm going to say anecdotally, I'll say in the last 5 years, cold climate heat pumps have evolved significantly, where these condensers will create warm air down to an ambient temperature of -17. Some manufacturers can even go down to -27. Like Austin was saying, heat pumps are they steal heat. They're very similar to your refrigerator. Your refrigerator is a heat pump. It's drawing heat from the inside the box and pulling it out. We're doing the same thing. We're pulling heat from the surrounding air and compressing it. But they do work. But and there are options. You can do backup electric coils if you're really concerned. We have clients that'll do 2-foot traditional 2-foot electric baseboard heaters. In a large bedroom or in a bathroom. There's always true heat under radiant floor, under slab electric heat. They're all options. They all work great. It's a comfort level. And with when you tie all this in with a renewable energy source like PV on the roof, you can quickly drive that utility cost way, way, way down. And you may not see, reality is reality. You may not see a zero bill 12 months a year. We may have a cold, cloudy February, and you may see a small bill that month. But in most cases, you'll develop a pretty robust credit, and the upfront federal tax credit is still pretty robust. It's 30%. And the state does give you a cash incentive for PV arrays as well. So it's not as heavy a lift when you went on a new build to put that array on the roof.
We'll talk. The third section of tonight is all about sort of rebates and what's out there,
We'll
both
get
for
there.
that all electric home, and we'll pick your brain as well, Chris and Bridget, on PV rebates. So heating and cooling, it is mini splits. Are there other options you're seeing in an all electric home? Is there anything else you're installing? Or you just said sometimes electric baseboard or radiant? But is it mostly just the mini splits?
Or ground source. You can go with a ground source heat pump if the house is designed and large enough to support that load. The ground source heat pump is a great option. Later on we can talk about the rebates for those, but it's pretty robust mass save incentives for ground source heat pumps.
Great. Well, I wanted to transition and talk about domestic hot water.
Hot water.
Yeah. Bridget, what's your insights to sort of options that are out there when it comes to domestic hot water, and what do you normally recommend?
Well, I'll just start by saying Efficiency Maine is very committed to electrification in a state that has, mostly delivered fuels. So we're seeing a lot of uptake in the heat pump market. We have over 100,000 homes in the state that are using heat pumps as their primary source of heat, or certainly throughout the heating season in a state that has only 500,000 homes. So, we're making a lot of progress there. And the heat pump water heater program is a big sort of piece to the electrification solution. So, folks can just go right to their box store and grab one off the shelf. Those are discounted right at the register. They save lots of money over a traditional electric resistance hot water heater. They make more hot water. They can be installed sort of DIY. You don't have to have a professional do that in Maine. If you do want a professional to do it, and it's more complex, right? You're taking your water off a boiler system, which is a typical scenario in Maine. We do have resources on our website to help you find a plumber and get that work done. But what we're trying to do in Maine is like bring that cost down so that we're winning every time there's a choice over a traditional electric water heater. We want people to go the most efficient route. Clearly, there's an Efficiency Maine rebate, sort of like instant. Then there is that federal tax credit eventually that people can take advantage of. And then there's just that energy savings year over year. So it's sort of our gateway measure. Like if you're going to do nothing, you do this first and see what you think.
Right. Yeah, it's like sort of that low-hanging fruit.
Yeah.
It's like, hey, let's start there. Step one. Austin, I'm going to throw this one to you because in our early iterations of houses, we're using a lot of instant hot water heaters, which in a small space, very efficient use of space, sits on the wall, in the closet, out of the way. What have you seen in the landscape shift, and how has it sort of impacted your work?
Yeah, absolutely. So we build small. That's kind of part of our process. So we're building between 500 and 800 square foot homes generally. It's hard to fit a heat pump hot water heater in that space generally. Traditional heat pump hot water heaters, they need about 700 cubic feet of volume in order to pull from. And we don't have a lot more than that in our houses. So we ran into this challenge of, even though we know that's the most efficient water heater available right now, we had huge space concerns. So we were installing instant on demand, which for a single occupant can work pretty well. And empirically, it can use less water because you're only heating the water as you use it. Once you get above one occupant, it becomes less efficient because it's got a huge initial draw of electricity. Some of the units we've installed draws like 80 amps right at once. And that startup amperage can really, it takes a lot of energy. So we have switched to what's called a ducted heat pump water heater. And we're able to duct our systems either into our crawl spaces and use that conditioned space. We can duct them into our homes. We can put louvered doors on places. So even though the heat pump hot water heater is taking up roughly 4 square feet of floor area, we're able to make it work in our small homes. So we've transitioned to that mainly actually for mass saves rebates require it, and because we wanted to do that for a long time. We'd still like to find a better option using an exterior, and there are options available with exterior heat pump units that come into a much smaller tank on the interior. They're just not quite mass produced enough yet where they make sense cost wise. But yeah, just like with the mini split, a heat pump hot water heater, same idea. You're stealing energy from one place and putting it into the water, and it can be a lot more efficient rather than 96% efficient or 100% efficient. It's 400% efficient in some conditions. So it's definitely a good transition, and we're trying to find ways in design that we can make it work, including the ducting.
There's a question from the audience, 2 really great questions. One is just clarifying that we're talking about a heat pump hot water heater unit, not to be confused with our heat pump mini split heating and cooling. So 2 separate systems using the same technology. So which is why we're talking heat pump, but heat pump hot water heater is what Bridget was just talking about with Efficiency Maine, where we get rebates. And then Chris, in Massachusetts, we bundle that all together with our new house and get those rebates. And Bridget, we'll talk in the next section on how does that work in Maine with the heat pump hot water heater and the heat pump unit versus in Mass where we bundle them together with new construction.
Yep.
Another interesting question. Hey, this section is the all-electric home. I'm heating and cooling with electricity with mini splits. I'm heating my hot water with a heat pump hot water heater. And then we all know, hey, lights, appliances, etc. Is in general, what are these different categories using on a hand wave percentage? And how can we use less energy or be more efficient living in those spaces? Who wants to start?
Yeah. I can start, and then maybe Chris would have some insight with his HERS ratings. But generally, we're at about 30% usage for our heating and cooling load. So that means only 30% for our style of home. That can go as low if you're building a full passive house. That can get down to numbers like 10% for heating and cooling, which means a majority of your energy use is actually in how you use the house. So are you using the dryer all year long, or are you hanging your laundry out? Dryers are traditionally another huge energy use. Are you cooking every single night? Are you baking roasts every single day for 8 hours? Sounds delicious. If you are, I'd love to give you my number. But it's how we use houses is actually because we are building them so much tighter and more energy efficient from an insulation standpoint. The energy use in general is more from how you live in the house and how you're using it, and less about how we're heating and cooling it, because we're already meeting standards with insulation. If you're in an older house, that is different, and I can let Brittany and Chris talk about that.
Yeah, sure. I mean, it is a holistic approach when we get into these all electric homes, and we, infiltration is probably one of the biggest aspects we need to look at when we're designing these homes. We need to get the home tight, but when we get these homes tight, we need to ventilate them right. So we need a balanced ventilation system, typically an ERV, which, if properly designed, can allow for the heating and cooling systems to be smaller than what we would traditionally have installed in our climate zone. We can really fine tune that delta T. We also look at what affects a hybrid heat pump or water tank would have on the indoor air quality of these small all electric homes. Heat pumps do create cold air. They do dehumidify quite a bit. So, when we're looking at these electric homes, it's a holistic approach, and the goal is to try to push all the design loads down as low as possible, which allows for a smaller renewable energy array, solar array on the roof. These are all the kind of the triggers to save and value engineer the project as we go. There's also points of diminishing return for insulation. We don't need to insulate these buildings to, an R90 shell. We see very well performing buildings with an R20 wall and an R49 roof, and good tight insulation, good tight infiltration rate, and good windows. And like Austin said earlier, we can look at the solar heat gain number for windows as we move around the orientation of the home. These are all the things that affect the overall performance and how much it's going to cost us to build them.
We have a great question from Kate, and it dovetails to what you just said, Chris. Hey, that heat pump unit dehumidifies. There is cold air. Are there other cons to installing these units? Saying, hey, they're very efficient. There are some space constraints, but what's the other side of that coin?
Yeah, for the hybrid heat pump or water tank, it will make a space cold. It is going to emit cold air. So depending upon where it's positioned in the house, if it's in a closet with a louvered door in the hallway that leads to the bathroom and there isn't another direct heat source, then that hallway can at times be colder. And yeah, they can dehumidify the home a little bit, which isn't the worst thing. I mean, we'd much rather have a lower relative humidity in the home than a higher relative humidity. We can much easier to deal with a relative humidity of 35% than it is to deal with one of 85%. Yeah.
And that's
Other
really
than
it,
that,
is the heat pump technology and
yeah, other than that, I
what
mean,
it's doing to the air. Yeah.
Occasionally the other issue is that the hybrid heat pump may not be in its most ideal situation or condition, and it will jump to a hybrid or an all electric function when it needs to. If it can't for some reason pull enough heat, it'll jump to that electric element. High demand or just the ambient conditions it's in.
So I think what Chris is talking about is the water heating element here, and not the air conditioning
hot
and
water.
heating. Right. Yeah. So in Maine, what we sort of recommend for the water heating and the heat pump water heating is a basement space, right? Like an unheated basement space, because it does kick out that cold air and you don't want to be competing with your central system. But for the living room, bedroom, living space, that heat pump that's doing the heating and cooling, besides heating and cooling, which is lovely. There's not many units that can do both. There's a whole host of other benefits, like the dehumidification we've already talked about, but the air filtration, right? There's an air filter that you can clean pretty regularly and make sure that your home has that sort of filtration ability, that air circulation, no combustion fumes, no fuel tank leaks, no sort of anxiety in monitoring your fuel level. In Maine, again, we do a lot of burning of oil or propane. And so that's nice to just sort of turn things on and they work. And then, in Maine, we have a lot of older folks too. So no heavy, inefficient window air conditioners, lugging those in and out, and then, taking advantage of Maine's increasingly renewable energy. renewable electricity on the grid. So those are just some of the benefits of the heat pump for heating and cooling. And yeah, I think that water heating piece in a small home on a slab that doesn't have a basement, it does pose a little bit, it's a trickier dilemma.
Tricky. But
Yeah, I think when we put the scales here, in both cases for the hot water heater and for the heating and cooling,
right.
they're certainly tipped in the pro category more than the con. There's a really interesting question. I think it perfectly wraps up, talking about the all electric home. What happens if you don't have electricity or there's power outages? There's all these benefits to the all electric house, but hey, we're still in the Northeast. We get those ice and snowstorms.
Yep.
What do you guys say to that?
Well, in Maine, we say, you're out of luck when there's a power outage and you've got a boiler. So, yeah, it's a toughie. So it's not necessarily a vulnerability for heat pumps. It's sort of a vulnerability period.
Right.
Yeah.
Right.
Yeah,
I mean,
that's
Massachusetts building code does allow for backup propane generators. Or, if the house has solar on the roof, then you can do battery backup. You can do, these Tesla walls are, they're good for about 24 to 30 hours, depending on the, the inhabitants' habits and what they're using it for. If you're just trying to keep the refrigerator running, they'll last for quite a while. We have a pretty resilient, energy grid. ISO New England usually gets everything back up running pretty quick. So yeah, I mean, as long as the sun comes out after the storm, your battery should stay running and your refrigerator is good and get a little bit of heat. There's options.
Yeah, I'll say, and I keep speaking to this. The other thing is just smart design up front. So we have a lot of empirical evidence. We have a home in Brunswick, Maine that we use as our office, and we had a stretch, I think, of 10 days without electricity, and the home was still at 56 degrees at the end of 10 days, and those were like 10-degree to -7-degree days, and that's from passive solar gain, and just from building a tight envelope. So when you build right from that standpoint, you're not going to lose heat anyways. But to Bridget's point, your furnace doesn't run without electricity either. There are certain type of propane heaters that run without. They're non-vented propane heaters that aren't great for your health anyways. And old farmhouses that have lots of air leaks, it might not matter anyways. But other than that, you have wood stoves, which I think, wood stoves can always be a part of a secondary use in an all electric home and be a good backup heat. But unless you have a wood stove or one of those propane stoves, you don't have backup. If the electricity goes out anyways, you're not going to have heat.
Right.
So it's not any different than that.
I guess in the interest of all electric, right? You can just like charge your house with your lightning truck.
Right.
Right.
That's one option.
Great. So the second part here, it transitions nicely because Chris, you brought up earlier ERV. We're going to flesh this out. What the heck is this? Austin, you just brought up this example of this house that out in the field is performing well. And so I sort of want to dive into and transition to like energy rating and modeling. Like, how are we putting all these pieces of the puzzle together so that when we go to build it, it performs the way we want it to? So Chris, maybe you could just give us sort of a high level overview of, for those who don't know on the call, what is the HERS rating and the modeling, just
Sure.
at a high level.
Yeah. So HERS rating is basically it's a scale, basically 0 to 100. You can go negative. We can go above 100. A code built home in Massachusetts, built to the 2015 IACC, should score about 100 at this point. New homes permitted today, all electric would need to hit a HERS 45. So how we do it, we basically take the building plans from the builder. We create a 3D model. We use SketchUp. Take that raw data, enter it, square footages of all the surfaces into the energy modeling software. Then we add in windows and doors, heating, cooling, and hot water equipment, ventilation, And then testing values, the duct leakage, if there's ductwork, the ventilation flow rates, the CFM of the fans and ERVs, and then the infiltration rate. And the software jumbles it all up and kicks out a score. And we use that to run different scenarios. So we can run scenarios to get the home to meet code, so to a HERS 45. We can run scenarios to get to 0. We can run scenarios to meet passive house. And we can kind of compare the outputs of the Ecotrope software or run rate software to, say, a Wolfie model for passive house, and use those to kind of, along with, so let me digress, along with manual J calculations for heating, cooling. We can fine tune that model and value engineer the build and say, prescriptively, Massachusetts has an R49 on the roof, but maybe in this particular house, because of the mechanicals and the low infiltration, maybe a 1 ACH blower door, we only need an R38. So we can start to save builders money while still producing the best performing home that we can.
And this is for that all new construction of, hey, I'm putting all the ingredients to the recipe together. Bridget, when you're approaching, hey, there's a home that's already sitting there and existing, how do you sort of look at, modeling or blower doors?
So blower door is required for our installation contractors. When they're filling out the claim form, they need to do a pre and a post. And really that's just sort of measuring the air leakage before you get started, and then, all of the great work that was done afterward. And at Efficiency Maine, we have these residential rebates available, just sort of like siloed. So people can pick and choose what they want to take advantage of. There's no sort of prerequisite. If you want to go out and buy a heat pump water heater, you want to, improve your water heating efficiency, great. If you want to also, tighten up the building envelope, great. And if you want a heat pump, great. Or you can just do those things independently. So we have like separate rebates assigned to each measure.
That's great to highlight, because this world that Chris and I are often in is like, oh, this brand new thing, right? We're building it from scratch. But there are those sort of different pathways. I want to dive into ERVs, like you brought up earlier, Chris, energy recovery ventilators. Austin, maybe you could give us a bit sort of like from that engineer perspective, why we're using them and how they work. And then we can talk about, different models or scenarios, how they're effective.
Yeah, absolutely. So if you imagine what we're building, what we used to build as humans were structures that had lots of holes, air could come in and out. We as humans produce carbon dioxide and we inhale oxygen. That's what keeps us alive. So when you have a relatively breathable home, like an old farmhouse, you get that supply of oxygen in, and you breathe out carbon dioxide, and it's able to sustain you. In the homes that we're building now, which we are building, our homes it's called an ACH 50, a blower door of ACH 50, which is basically 50 pascals of pressure, how much leakage there is. And we reach a number of 1 generally in our homes. Passive house is down around 0.6, or it is 0.6 or lower. And the state requirements in Massachusetts are 2 now. Is that right, Chris?
3.
3. There's still 3.
3. Yep.
So those are blower door requirements, but that basically is like if you put your head in a Gore-Tex jacket. So our houses breathe some vapor, and we allow them to do that. But otherwise, you're in a Gore-Tex jacket, and in relatively small spaces, that means that you're producing carbon dioxide. And unless you're opening windows or doors, which you generally are probably not doing in the winter, you need some way to get oxygen in and to get the carbon dioxide out. So that's where ERVs come into play, or HRVs. An ERV is an energy recovery ventilator. An HRV is a heat recovery ventilator. I'll start with HRVs, which basically what those do is they take the air from the inside, they pass it through a core, which saves up all the thermal energy in it. And then it goes outside, so it exhausts all your CO2, but it keeps the thermal energy. And then it takes in oxygen from the outside, passes it through that thermal energy so that you can keep all that energy that was in the house without losing it, and brings it in. So you get fresh oxygen that's slightly tempered from the air leaving, and that's called an HRV. An ERV is similar to that, but it also tries to balance the humidity a bit more. So instead of losing all the humidity and just taking in whatever the humidity is from the air outside, it balances the humidity a bit more. So depending on the season, one or the other can be important. But either way, they're both ways of ventilating your home without losing all of that energy. Which, if you open a window, that also ventilates your home, but you lose all that energy that you've built up in the house.
Great. So how are you, when you're approaching a new build, Chris, how does that component factor in? What are you thinking about
So
there?
we're looking for ERVs that self-balance. We're looking for ERVs with low wattage to CFM ratios. Something that uses, has a high CFM rate of moving air with a low wattage use. And we look at the design. We look at where the return air, where the air is that we're drawing out of the house. And where we're delivering the clean, fresh air to. So in a really small, in an 80, in a small space, if that ERV return, the air that's being drawn out, is in the same space as the heat pump we're using to heat and cool the space, you can use the ERV to help move the air around. Which will reduce the need for more heat pumps. So it's a double do. We can also use the ERV to ventilate a bathroom. So we can draw the hot, humid air, contaminated air from the bathroom, remove that humidity, bring the clean, fresh air into, say, the bedrooms, pressurizing those bedrooms, dealing with the CO2 levels, and using that ERV to kind of do double duty as the ductwork for kind of conditioning the house as well as maintaining a good, clean indoor air quality.
You're approaching this as that, third-party energy rater. How do you work with builders when they're, or architects? You're drawing up these plans. You know all about this equipment. How does that interface happen?
So we it's a fine line we have to walk, because as HERS raters, we're supposed to be verifiers. We're really not supposed to consult. We're not supposed to tell anyone what they're supposed to do. In our case, we probably straddle it a little too close. But what we normally tell builders is, I did 2,000 HERS ratings last year. I'm just going to tell you what worked in those 2,000 homes. It's probably going to work in yours. And we'll say, this particular ERV, so maybe like a Brone 1, this 100 CFM Brone unit that self-balances. It's a great unit. Fairly cheap. They're like $950. They will they'll Bluetooth connect to indoor air monitoring devices. This Overture, and kind of it'll maintain the indoor air quality automatically over 7 days a week. In traditionally when we ran bath fans a lot to maintain indoor air quality, or some of these older style ERVs that kind of ran indiscriminately for all day long. If there's no one home, the ERV or the bath fans don't necessarily need to run. The indoor air quality is good. So with these self-balancing units, they can basically shut themselves down when they know they've kind of reached their threshold. They know where they're supposed to be, and that saves us money as well. It's energy savings.
Great. Yeah, that's really insightful. So, hey, I've this body of knowledge, plus I know a lot about these products of what's worked empirically. So going along that vein, hey, we do all this modeling up front. The builders and designers are speccing, you're verifying. We're concocting this recipe of hot water, heating and cooling, appliances, etc. How are these actually performing? Austin, you talked about that house up in Brunswick. What have you seen over the past 5 years as, these, code has gotten more strict, these new technologies have come out, and we're adopting them both in the new construction world and then also, like you've seen, Bridget, the retrofit world. So how are they performing? What do you see, Austin?
Yeah, fantastically. So the example of the Brunswick house that I was talking about, we use that as our office, and to the point of 30% of the heating load, or 30% of the total energy use just being the heating load. Generally, all we're using in that building is we use it as an office, right? So we're there during the day. We use some lights, we use some very low energy laptops and screens, and then otherwise we're just heating it. We're not doing laundry there generally, and we're not using a lot of hot water other than to wash our hands or maybe wash dishes. So you look at that house, and that's easily net zero. We sized our solar array based on our HERS rating for that, which would include typical use. It's a 2-bedroom unit. So that one we are way under our energy budget, and we have a surplus of energy, which is great. Generally on our homes, we are at or below what our energy rating is. We can get very close, especially with the heating and cooling load and the hot water load. We can get pretty close. I think the big variables are things I mentioned before. If someone is doing a lot more laundry than typical, or they're taking 6-hour long showers, then that obviously adds a lot more energy. And especially on a low energy house, it's a lot easier to move the needle. So even showering for 10 extra minutes a day makes a big difference on your energy bill at the end of the month. But generally, Tim, our HERS raters are really good at narrowing right in on our energy usage. And in the around 70 homes that we've built, I'd say on average, we're within 5% of that energy use, high or low. It's pretty impressive.
Hey, that's great. There's a question from the audience here. It's asking about sort of carbon capture products in buildings. So we're saying, hey, we're all electric, we're using energy. How are we, either offsetting that electricity with PV, but how can we actually capture carbon in that structure? Austin, that might be more tailored to you of products you're seeing or recommending for carbon capture.
Yeah, and maybe I don't know of them, but there aren't a lot of small scale carbon capture devices that you can use within your house. So, and let me know if I'm understanding you wrong, but generally carbon capture is the idea that we're going to capture carbon out of the air as a way to prevent it from affecting our ozone and going up into the atmosphere. Generally for at-home products, there aren't really carbon capture products other than plants. So if you have lots of plants, that's a great carbon capture for CO2 generally.
I think it might be more along the embodied carbon.
Right. I was going to say, I think this, more of an embodied carbon.
Right.
So concrete and like wood fiber insulation, timber HP or Gutex.
Great question. Yeah, so if anyone's familiar with Timber HP, they use waste wood product to make wood. So wood is carbon, generally. Natural things are carbon. So it's natural embodied carbon. So and studs do that. If you've heard of mass timber, all of that, they take a lot of carbon, and that's from a plant over its life, stealing all the carbon from the air, and then we can keep it in there as long as we don't burn it. Or as it decomposes, it also emits carbon. So by building these into our structures, wood is a great carbon sink where we can keep carbon. On the other hand, concrete is a really bad one. So concrete is a huge carbon emitter, especially up front. We talk about a carbon life cycle and the upfront carbon to build something. And if you build purely with concrete, it's got a huge upfront cost in carbon. So at Backyard ADUs, we try to use as little concrete as possible. We've developed details to scale back our concrete use from a typical frost wall by almost 60%. We use about 40% less concrete in order to combat that. But yeah, wood is a great way, and using more natural products that take less processing to create is another great way to make sure you don't have a bunch of upfront carbon.
Great, thanks, Austin. So
Sure.
questions have been trickling in, keep them coming. But let's transition to the third part tonight. And it's really all about sort of incentives and bills. We've sort of been circling this topic, talking about, cost per kilowatt. How are people actually, what are your electric bills going to be? How can you offset them with a source like solar? So Bridget, maybe you could start and just tell us what's sort of out there in Maine and what does that look like for rebates?
Sure. I will just start by saying, if there are people on the call who are living in Maine, our website, efficiencymaine.com, has a bunch of tools and calculators, and people can go and put in their own sort of consumption data and spit out what their anticipated, savings will be. But on average, we say moving from a traditional electric water heater to a heat pump water heater over the life of that unit would save families about $5,000. We also claim on the website that moving from a oil heated home to a heat pump heated home, so primary fuel is now heat pumps, typical Maine home, family of four, that's going to save about $730 annually. And we update those costs like I think quarterly on our website because things are always changing. But those are just sort of like some typical savings. But again, our website has those calculators. The incentives are sort of tiered by the income category of the homeowner. So anyone who's interested in a heat pump project will need to use those heat pumps as their primary source. So just not like an AC or a supplemental, but really leaning on your heat pump as at least 80% of your heat load in the wintertime. And the rebates associated would be $1,000 per outdoor unit, up to a maximum of 3 for anyone. And then if you're a moderate income Mainer, that doubles to $2,000 per outdoor unit. And if you're a low income Mainer, it's $3,000 per outdoor unit. So we've got a verification process on the website. But so that's heat pumps. Our insulation is a little different. It's sort of percent of the project cost. So for low income Mainers, they want to have an insulation project done. The rebate would be 80% of the total cost, up to a cap of $8,000. So on a $10,000 insulation job, Efficiency Maine would cut that check for $8,000. And then $6,000 for moderate income and $4,000 for everybody else. The water heater, again, that's discounted right at the counter when you're purchasing that equipment or at the distributor.
How does that work between you, Efficiency Maine and, say Austin, the builder? Who's filing those? How does the homeowner work in that matrix?
Yeah, that's
in
a great
Maine?
question. So there's a claim form, just needs to be filled out. And the contractor doing the work needs to be affiliated with Efficiency Maine. So on our website, we have a huge database of everyone in the state that does the work. They're all independent contractors, but they've filled out, their basic credentials. We have their, insurance certificates and things like that. So they're all on the website. Folks can just go on the website, sort by their zip code and whatever service they're interested in, and then it will populate those contractors who've done the most work for Efficiency Maine would be at the top. We also have a call center, and their primary function all day long is to just pair customers with contractors in their area so that they can get started.
Amazing. Thanks, Bridget.
Yeah, thank
And then
you.
Austin, I know on the back end, you're helping homeowners get those rebates, right? To fill that stuff in.
Yeah. Yeah, we're generally informing them, though Efficiency Maine is pretty good with their marketing materials, so most of our clients know about the rebates. And then we're obviously filling them out for them as we are a certified installer of heat pumps, but our plumber is a certified installer of heat pump water heaters. We also use other folks who are certified installers. And yeah, we help them fill out the rebate forms and then they get a check mailed directly to them. It's a rather smooth process.
An interesting question from the crowd. What's the average rebate for a typical ADU in Maine? If you were to put all those different ones together for a ADU project, what do you think it would be?
Yeah, generally around a few $1,000s. So between $3,000 and $5,000, depending on income. And that's for the heat pump water heater. And this is for new construction because we build modular. So we're generally building new construction. And that's between the heat pump heating system as well as the heat pump water heater. The total rebate we're getting for our clients in Maine.
Great, thank you. And Chris, so pivoting to Massachusetts, I know, sort of different set of regulations there.
Yep.
But what are you doing to basically, get folks rebates, and how does that work?
Sure. So we have a tiered strategy. So we start with Mass Save. Mass Save, single family, residential, new construction, 1 to 4 units. The incentives are $7,500 up to $11,250. And then there are additional riders for Wi-Fi thermostats, induction cooktops, split system heat pump water heaters, so something like a Sanco 2, where it's an outdoor heat pump condenser with a indirect storage tank. Energy Star version 3.2 certification is a rider of $250. The DOE Zero Energy Ready certificate, that's a $500. And then, like I said earlier, ground source heat pumps is a $9,000 rider. So the installation of a ground source heat pump will be $9,000. Renovations and additions are slightly different. That's still a paid forward savings calculation based on the existing house before any work was done to the as built completed home. So there's a metric that measures the energy efficiency improvements, along with whole home heat pump replacement rebate of up to $10,000. So in average Massachusetts renovation, full gut renovation, we'll get somewhere between 15 and 30,000 in Mass Save incentives. A traditional ADU would get somewhere around $7,800. And then on top of that, we add on. So there are alternative energy credits that are available that can be sold. They're similar to solar SRECs. So it's a quarterly auction. The value changes a little bit from quarter to quarter because it is a commodity. It is traded. But that's usually if the HERS score is 50 or less, you should get about $1 a square foot. So ADUs, you're looking at, another maybe $1,000 on top of the 78. And then if the home meets the Energy Star certification criteria, that's another $2,500. And then DOE Zero Energy Home $45 tax credit is $5,000. So we can slowly build on the credits and get a really good house. Somewhere around 15,000. Which is not bad, pretty good.
And you're doing, hey, we're doing the modeling up front and then going and assess what's actually there.
Yep.
What
Yeah. So
what
I mean,
sort of certainty do you work with between those two?
well, I mean, when we do our initial preliminary modeling, we look at obviously code compliance first, but then a close second is optimizing the incentives and then value engineering the project. We don't want to see anyone overspend on something that when it doesn't increase, there's an increased benefit. So it kind of a threefold approach, to build the best house we can for the least amount of money, and then optimize those incentives the best we can, and um, yeah,
Yeah. And over
that's
the past handful of years, as construction costs have gone up, it's been
yeah,
really nice to have these rebates, sort of light at the end of the tunnel. It's
right,
always nice to get a check coming back
right,
after you've
right, right.
spent something. So, two final. Timothy has another clarifying question for you, Bridget. So really, like, let's say we're doing a new build ADU in Maine. It's
Mhm.
really just a credit for the heat pump, heating and cooling system, and the heat pump hot water heater. Those are the two. The
That's
insulation
right. Yeah,
wouldn't count.
insulation wouldn't apply to new construction, only retrofit. So, but the other two that you named, the heat pump for heating and cooling, and then the heat pump for water heating, those two would apply.
Great. So I sort of want to end with, take it either way. What's the one thing you wish would change with the code? Or where do you think the code is going to go? Like, we're building the all electric house right now. It's like a Ziploc bag, it's airtight. We have the heat pump
Mm-hmm,
hot water heater, the mini split
mm-hmm.
system, heat pump um, heating and cooling, the HRV or the ERV breathing for this airtight bag. There are incentives out there. Where do you think things are going to go? Where would you want them to go? Who wants to start?
I'll start on that one. So my current side project is indoor air quality. I feel that as a region, New England as a whole, we've moved past the function of the ASHRAE 62.2 formula, that bedrooms plus one way of calculating what the ventilation needs for a house. Canada has a unique metric now where they essentially do a block load similar to a manual J, and each individual room is modeled to the ventilation that's most appropriate for that space. So a kitchen would get more ventilation than, say, a guest bedroom that was hardly ever used. The next step, which is what we're working on now, is automated 24-hour monitoring. So this indoor air quality monitors that, VOCs, CO2, particulates, relative humidity, so that buildings aren't arbitrarily, we don't have fans running arbitrarily. If the indoor air quality is good, then nothing needs to run. We shouldn't have fans running, bring ambient temperature air in when we don't need to. So that would be my biggest desire for a change in code, is a change in the way we calculate ventilation rates for new and existing residential structures.
Great. Thank you, Chris. What do you think, Bridget?
Oh,
What would you like to see?
No comment. I mean, where is it going to go? Who knows? It's sometimes a blessing, it's sometimes a curse, what the codes are. So, we at Efficiency Maine, we generally like take a pretty big step back from codes, and the independent contractors who are doing the work adhere to the codes that are applicable for that municipality, but we don't get too involved.
Maybe I'll push you a little bit. If hey, Efficiency Maine is doing all this great work to help people have more energy efficient homes, is there other things you'd like to see them incentivize, or information you'd like people to know about? Yeah, having
Yeah, I
living in a
mean,
more efficient space. Yeah.
we've been folding in EVs to our suite of offerings recently, and that infrastructure in Maine has, we've been working on that. Certainly, we are fans of solar. That's not a rebate that we offer in Maine, but we have information on our website because it's certainly a great idea and it couples so nicely with the rebates that we do have available. So there's a lot of great work out there that's sort of ancillary to the rebates we're offering, but we've we've got information on our website to support that.
Great. Yeah, I know that's a big one too. With all the new electric vehicles that are out there. And Austin, we'll end with you. What do you think?
I think I'm always harping on this, but education. So prescribing something without educating is always really hard. And we hear this a lot from some of our older subs and from our older contractors, colleagues. It's like, oh, they changed the code again. How can we do this? How can we build? But Tim, you know this, we're also one of the lower cost builders that we know. And we're able to do that because even though we're building net zero energy ready, we build smart. And we build smart because we have a lot of knowledge on our team, which is great. We have a lot of cool resources like Chris, who do great things. But I think the education part is really missing every time we have a code change. Maine just underwent a code change. Mass just underwent a code change. And for the average, average carpenter or the average construction company, they don't have good education directly from the people changing the code. They're just expected to learn it on their own and figure it out, and they don't know the reasons why it's important to have some of these code changes, especially from an energy efficiency standpoint, how it can actually save their clients and save them money by building efficiently, and in the long run it can be a great thing for them. So that's my big thing is education. We need to couple education with any code changes that we ever do.
Awesome. Well, thank you, Bridget. Thank you, Chris. Thank you, Austin. You've been a wealth of knowledge tonight. Timothy in the audience said, hey, next time we need a list of abbreviations and acronyms to find. So maybe next time we'll have a cheat sheet.
Right.
A lot of great information and technical knowledge. So thank you guys for your time and your expertise tonight.
Thank you.
Thanks, Tim.
Have a good night.
Hi, everybody. Thanks for joining.
Thank you, everyone.
Take care, Chris.
Thanks, Tim. I'll talk to you soon.